What is the value of x? Solution. Label points A, M and D, locate the center O of the circle. Join line OB and line OA. Also, join line OM equals R, the radius of the circle. Since it is an equilateral triangle, angle A equals angle D, which equals to 60 degrees. Consider triangle MOD. Are divided by line M, D equals to tan 30 degrees, which equals to 1 divided by 3. Cross multiply and we have that line M, D equals the product of R and the square root of 3, which equals to line MA. Redraw the figure and label points B, C, F and G. Join line DG. Let angle FDG be equals to alpha. This implies that angle CDG equals 60 degrees minus alpha. By trigonometric identity, line CG divided by line DG equals sine 60 degrees minus alpha, which equals to 75 divided by line DG. Cross multiply and solve for line DG. It follows that line DG equals 75 divided by sine 60 degrees minus alpha. We call it equation 1. Also, line FG divided by line DG equals sine alpha, which equals to 27 divided by line DG. Hence, line DG equals 27 divided by sine alpha. We call it equation 2. Equate equation 1 and equation 2. So that 75 divided by sine 60 degrees minus alpha equals 27 divided by sine alpha. Cross multiply. It signify that 75 divided by 27 equals 25 divided by 9, which equals to sine 60 degrees minus alpha divided by sine alpha. We call it equation 3. But sine 60 degrees minus alpha equals the result shown on the screen. That is, half of square root of 3 times cosine alpha minus sine alpha. Substitute into equation 3. It implies that 25 divided by 9 equals the square root of 3 times cosine alpha minus sine alpha, all divided by 2 times sine alpha. Cross multiply. Expand bracket and simplify. We obtained that 50 times sine alpha equals 9 times the product of the square root of 3 and cosine alpha minus 9 times sine alpha. Combine like terms. It implies that the sum of 50 times sine alpha and 9 times sine alpha equals 9 times the product of the square root of 3 and cosine alpha. Simplify further and divide equation by cosine alpha. We obtained that 59 times sine alpha, all divided by cosine alpha equals 9 times the square of root 3. Also, divide the equation by 59. So that sine alpha divided by cosine alpha equals 9 times the square root of 3, all divided by 59. Finally, sine alpha divided by cosine alpha equals tan alpha, which equals to 9 times the square root of 3 divided by 59. We call it equation 4. From triangle CGD. Line CG divided by line CD equals tan 60 degrees minus alpha. Substitute values. This implies that 75 divided by line CD equals tan 60 degrees minus alpha. We call it equation Y. Use trigonometric identity to find the value of tan 60 degrees minus alpha, as shown on the screen. Substitute equation 4 into this equation of tan 60 degrees minus alpha. We obtained that tan 60 degrees minus alpha equals 25 times the square root of 3, all divided by 43, after simplification of substituted values. Now, substitute this result obtained into equation Y. Cross-multiply and we have that line CD equals 43 times the square root of 3. Label points J and K. Join line OG, line OJ, and line OM. Each equals to R, the radius of the circle. It implies that line CG equals line KM, which equals to 75. Hence, line OK equals R minus 75 and line MC equals line KG, which equals to R times the square root of 3 minus 43 times the square root of 3. Also, line OG equals the radius, R of the circle. Consider triangle GKO. By Pythagoras' theorem, the square of line OG equals the sum of the square of line OK and the square of line KG. Substitution values, and we obtained an equation shown on the screen. Expand brackets, collect and combine terms in one side of the equation. It follows that 3 times the square of R minus 408 times R plus 11,172 equals 0. Use general quadratic equation formula, where A equals 3, B equals negative 408 and C equals 11172. 4. R equals negative B plus or minus the square root of the square of B minus 4 times the product of A and C, all divided by 2 times A. Substitute values and we have that r equals 98 or 38. After simplification of substituted values. Since line CD is less than line MD, therefore, r not equals to 38. Hence, r equals 98. Now, label point P join line OA. It implies that line OA equals the sum of line AP and line OP, which equals to the sum of line AP and R. Consider triangle AOM. Line MA equals line MD, which equals to R times the square root of 3, and line OM equals R. Using Pythagoras' theorem, the square of line OA equals the sum of the square of R times the square root of 3 and the square of R, which equals to 4 times the square of R. Substitute value of R. This implies that the square of line OA equals 4 times the square of 98. Take the square root of the equation. It follows that line OA equals the square root of 4 times the square of 98, which equals to 196. But 196 equals the sum of line AP and 98. Hence, line AP equals 196 minus 98, which equals 98. From triangle APB, line BP divided by line AP equals sine 30 degrees. Substitute values. And we have that x divided by 98 equals sine 30 degrees, which equals to half. Cross multiply and solve for x. This implies that x equals half of 98, which is equals to 49. Therefore, the required value of x is 49 units.